Hello, everyone, and welcome to today's webinar, Sound Masking in Modern Facilities. I'm Ann Cosgrove, the Editor-in-Chief of Facility Executive Magazine, and this webinar today is presented by Cambridge Sound Management. Thanks for joining us. Before we get started, I would like to cover a few housekeeping items. First, please note the control panel that is on your screen. This is where you can submit questions in the question box in that panel. Please send those questions in at any time, and your speaker will address them after the presentation. Also, please note the orange arrow on the left side of the control panel. Clicking on that arrow will either expand or collapse the control panel, so please be sure that is expanded so that you can access the question box. Also, if at any time you experience a technical difficulty, please send a message to us also in that question section, and someone will address it for you right away. Now I'd like to introduce your speaker, Balazs Baldag. He has been with Cambridge Sound Management for 5 years, during which time he has held positions from inside sales to field sales engineer, to most recently the Northeast Regional Manager position. He's seen the company grow from 10 employees to approximately 70, and he has personally installed a few thousand emitters while working with the company's installers. Now, before we hear from our speaker, we do have a poll question we'd like to ask you all to weigh in on before we get started. As you know from the title, we'll be talking about sound masking today, so we just wanted to ask a simple question of you. Are you familiar with sound masking? So please take a quick moment to let us know yes or no. We'll show the results when the voting is in. Okay, so we have 78% yes, you're familiar with sound masking, so that's a good thing. And 22% answered no. So great. All right, thank you for that. So without further ado, I will hand it over to Balazs. Good afternoon.
Hi, good afternoon, everyone. Thank you so much for that introduction. As you had mentioned, my name is Balazs Baldag. I'm the Regional Sales Manager with Cambridge Sound Management. Cambridge Sound has been around now since 1999 when Jack Hine, our founder, he's an MIT acoustics graduate, certainly an expert in the field. He started our company, and actually we are a direct descendant of both Bernack and Newman, which I'll also touch on a little bit later in this presentation. And Bernack actually invented sound masking when he was sitting in a library overhearing a fan, and as soon as the power went out, all of a sudden he realized how well he could hear other people in the library. So he started to devise the first electronic means of sound masking, and we're actually direct descendants of that. We are the world's #1 sound masking manufacturer. We have a host of products that really allow us to tailor a solution to your direct issue in your facility. So without further ado, let me jump into this. So this discussion is going to touch on sound masking and how we can utilize it in modern facilities. With all of the changes in architecture and furniture, the use cases for sound masking have really, really taken off. So what we're going to cover today, so acoustic privacy. So we're going to go over the important aspects of acoustic privacy, what it means when you have it and when you don't. It'll be pretty apparent, I'm sure. The ABCs of acoustics, basically a quick formula that we can use to devise a plan to better improve the acoustic privacy of our space. And then speech privacy, it's an absolutely vital piece of the puzzle as well. Sound masking, so where sound masking comes into play and what it can do for your facility. And then some common design issues, what you'll face when you build out a space with and without sound masking, and what can be done to make it even better. I'm sure that picture looks pretty common to a lot of you. There's a lot of glass, a lot of reflective surfaces. So a very common space, and very likely this is a boardroom or a space like that, and more than likely on the other side of the glass there, you've probably got a reception area that just about anyone off the street can walk into and overhear those very sensitive conversations. I don't know if a lot of you have facilities like this, but out of the last 100 or so sites that I have been on, if 65 to 70 did not have a layout that very closely resembled this, I would be surprised. So anyways, I kind of got lost there on a little tangent, but so the case for acoustic privacy, and I'm going to read this word for word because it really gets the point across. So I currently work in a cubicle. My neighbors are a man in the midst of a divorce, a woman with a problem child, another woman with an elderly parent who should be in a care facility. The only cure for my personal hell would be a quiet room with a door. Perhaps my employer would then get his money's worth from my workday. Did I mention that I'm across from the copier? So this is a very, I mean, as ridiculous as it sounds, it's really not that ridiculous. I know when I was in the office, many of these same points really kind of applied. So what do you do about this? Well, this graph here is now going to show us basically a rating of different levels of satisfaction, I should say, with people in their space and the different attributes of the space. So here we see on a scale of extremely dissatisfied to extremely satisfied, the ones that I jump to right off the bat are going to be thermal comfort, because no two people that I know can ever agree on the temperature. I will be sitting at home watching a show with my wife, and she will literally have, you know, a sweater on, sweatpants, fuzzy boots, and a blanket, and I'll be sitting there in shorts and a t-shirt. She'll, of course, still be cold, and I will, of course, still be warm. And much of that same kind of theory can still apply to the office, to our everyday lives in the office. Well, if we look at this, acoustic privacy comes in well below the thermal comfort. So people are actually less satisfied with the acoustic privacy of their space than the actual temperature. And that, you know, there's a lot of other points on here. You know, maintenance, general satisfaction is pretty high. People usually really like their office layout and the different tools they have to do their job with. Air quality is usually okay. Acoustic privacy, not so much. So some employer concerns, and I really like this this slide here because it drives home a really important point. Regardless of the trend in furniture, and very, very likely in your buildings as well, where you have a lot of open office areas, probably not so much private offices anymore. And really, we're going to a collaborative type of environment. I say going to, that trend has been there for the last 30 some odd years at this point, so it's been alive and well and still continuing that push. However, your employees, in the majority of respondents, at least in this case, where Steelcase had actually reached out to almost 30,000 respondents over the course of, I believe, 4 years or so, 54% of workers in this 30,000 actually felt that they were really individual workers, that they weren't collaborating all the time, and 80% of their work is actually spent doing individual work, as opposed to only 46% of respondents that felt that they were actually collaborators, and they spent 61% of their time collaborating. Now, this is interesting because this comes from Steelcase as well, you know, the world's largest furniture manufacturer and seller. And, you know, most of the stuff that they sell is obviously for open office. So just kind of interesting there to note that. Now, there's certainly some very specific concerns as it relates to a particular industry. For example, HIPAA with the HCAP scores, very, very important. So if you happen to be in facilities for a hospital, this is vital. We've seen such huge growth here, and this is probably not going to be news to a lot of you that are more than likely already familiar with sound masking as it relates to a healthcare type of an environment. But we can greatly help improve the HCAP scores. We've got countless hospitals masked at this point, and in every case, the results have just been absolutely phenomenal. So there's ASTM, American Standards for Measurement, LEED certification. I won't get too into the details on all of those different points, but without further ado, I want to jump into the ABCs of acoustics here. This is really important. This is kind of the formula that you can use to make your space as pleasant as it relates to acoustics as possible. So although we can actually expand on this, we can make our way well into the alphabet, but for the sake of brevity and to highlight the most important ones, we'll go with just the ABC. So A, it's probably going to be fairly obvious to some of you. That's absorption. So your acoustical ceiling tiles, wall panels, carpeting, essentially anything warm and fuzzy. I mean, you can literally have people in a space absorbing sound because they're wearing fluffy sweaters and things of the like that. Um, Although that wouldn't be a typical design point that you'd be able to utilize, regardless, anything that's kind of soft, absorptive, that basically absorbs energy and then burns it off is something that we can certainly use. Now, blocking, another one that's going to be fairly obvious. So anything like a cubicle partition, a wall, a door, anything that's in front of that message, whether it's intended or not, and some sort of a device to block that message from making its way to the other side. My personal favorite, especially in a conference, not a conference, but rather I should say a call center type environment, is a partition that's glass usually, and it's about 3 or 4 inches separating 50 people or so that are directly facing one another. And this pretty partition is supposed to not only look good, but also to help keep conversations in their intended space. Well, it doesn't really work like that, but we'll get into that later as well. C is covering. So this can be a lot of things. It can be anything from your HVAC to a fountain, a waterfall, traffic noise, and then of course there's sound masking. Anything to bring up the ambient sound level or that noise floor a little bit can act in some way, shape, or form as a masking system, or better yet, just covering. So with cover, that's where we're going to spend the majority of our time going over. So that's what we're going to certainly focus on with this. So here's an open plan area. And again, I'm likely not saying anything overly new to most of you by going over this. So in a typical open plan area, we're getting obviously lower partition heights. It was interesting for me because I saw that in our own offices in Waltham. We moved from not only to Cambridge to Waltham, but from Waltham from one side of an office building to another. And when we made that move in the period of about 2.5 months, more like 3 years, I saw the partitions come down by over a foot. And just that move from one side of the office to another office, or to another suite, I should say, in that office building, they came down substantially. Not only that, but the cubicles became a little bit smaller. We took off some of the cubicles, and they are now a good deal more dense. We're getting more people into the space to get more utility out of it. More reflective surfaces? Absolutely. I don't think we have too many architects on the line here, but we might. But they absolutely love the use of glass, marble, sheetrock, anything that is extraordinarily reverberant and essentially absolutely horrible for acoustics of the space. But there's more and more of that. So an enclosed area, you'll notice we call it an enclosed area and not a private office for very good reason. Although you may have a private office, it's probably not that private. If you're sitting in a private office and you can overhear your neighbor in another private office, guess what? There's a pretty good chance that they can hear you. Or if you're sitting in a private office and you can hear the people outside, well, guess what? They can also hear you as well. So this becomes quite critical to understand. And one very important distinction, just getting somewhat sidetracked here, is that sound masking is always applied to where you have the listening party or the unintended listeners. So if I'm in my office and I don't want people outside of my office to understand me, then I am now masking the open office areas. Sound masking in that case is being applied to the open office areas around me. If there's an issue with me understanding the person in the adjacent private office, then you want it in those private offices. So anyways, with those enclosed areas, we have a lot of demountable walls. I see quite a lot of them, and a lot of times they are actually utilized to create a different kind of a space for a different use case. So say one day it'll be a conference room, and the next it gets moved all together, and then it becomes a large open office space for someone to hold a company meeting or to give some sort of a presentation. We're starting to see a lot of that. Much fewer walls going to the deck, it used to be standard to take the wall all the way up to the deck, but now to save on all sorts of materials, labor, and everything else, we're seeing a lot of decks that aren't, I'm sorry, walls that going all the way to the deck. And then, of course, there's an increased use of glass. Glass is everywhere. My personal favorite is glass around like a conference room or a boardroom. Again, I keep coming back to that example, but you know, you have these very sensitive discussions in there, and yet you make a room that's basically a fishbowl that anyone in the space has access to and can see right in. And the funniest thing is that usually they're right next to a reception area that people that aren't even employees of the company have access to. I find that kind of interesting. But so speech privacy. What exactly is speech privacy, and how is that measured? So we'll go over some, how can I put this, research that really has decades of research behind it. And this is a very important point. So if you take home one point, be sure to take home this. It's speech privacy is the inability of an unintentional listener to understand another person's conversation. That's vital. So when we can understand that it's actually about intelligibility. It's how much you can actually understand of the conversation. I was actually in a meeting last week where someone came to me, an end user of a big firm, was like, well, our sound masking system isn't working. I'm like, well, how come? Like, I can hear them talking right down there. And he was pointing to a group. They were probably about 22 to 25 feet away. And yeah, you could hear him mumbling something. I'm like, well, can you hear him? He's like, yes, I can hear him. And then I asked him, well, can you understand what they're saying? He's like, oh, no. So then he starts walking over to them, and we're within like 15 feet. I'm like, well, can you hear him now? He's like, yes. I'm like, can you understand him? No, still can't understand him. And that's the point. That's it right there. When you understand someone's conversation, then you begin to pick up on it, you begin to pay attention to it, get distracted, etc. That's where that distraction and the privacy issues happen. It's not if you can hear someone mumbling, you know, if you have the murmur from like the Peanuts gallery or something like that, it doesn't matter. You're not going to get distracted by that. So speech privacy complaints are due to distraction caused by overheard conversations, right? That kind of makes perfect sense. There's not really saying a whole lot with that. Now, the perceived level of distraction relates directly to the intelligibility of the overheard conversation. That's very important. Again, it's what you can understand that begins to distract us. And this is basically a signal-to-noise ratio, like most things, speech or audio, that the intelligibility actually depends on the loudness of that signal or the overheard speech to the loudness of the background noise or just noise. So the privacy index. How private, excuse me, had to drink some water there. How private actually is my conversation? So at 0, you've got, well, okay, I've got basically no privacy. So it's you sitting on the other end of this, listening to me through headphones, a set of speakers, whatever. You understand just about everything. So that's no privacy. Unacceptable privacy is where still about the majority of the conversation is not intelligible, but you're still making out quite a lot of words and probably enough to piece something together to the point where it is distracting. That is when we get into that 60% or so area. Minimal privacy, so that's probably where the majority of workspaces are these days, towards the lower end of that and probably nowhere near the 80% unless they've already got sound masking or a ridiculously loud HVAC system. So this is our goal. Normal is really where we want to be for open offices, and then of course the 95 being more towards the private offices. Anything that would get us into like a 100% would be a space where basically where I was at yesterday, or a skiff where we have to have 100% speech privacy. And then 95%, like I said, would really be where we have that private office. And then when you make your way over to 100%, you're essentially looking at a skiff type of an area. So the speech privacy potential, this is a pretty neat way to get a measurement and to really kind of piece together what you have in your space and how you can make your way towards increasing your your speech privacy. So it's developed, of course, and used primarily by the government. But what this does is it's the sum. So you're taking your noise isolation class and your noise criteria, and you're adding those two sums together. So basically, you're taking your STC ratings, I'm sorry, NRC ratings in this case, and you're adding that to a background noise, whatever the background noise is. And that number is going to be the amount of speech privacy potential that your space actually has. So if we look at this graph right here, this is now going to show us what we've got. So if we're looking at the very bottom here, you've got less than 60, you have no speech privacy. You make your way over to good, you're at 75. Normal voices are audible, mostly unintelligible, whereas raised voices are somewhat intelligible. We go to highly confidential, which is pretty important because, again, it's really our goal. Start out around 85%. Normal voices are not audible. Raised voices, barely audible. And then above that, you've got, just a great rating. So what we want to do is, quite obviously, figure out what kind of space you have, what your audience is, what kind of people and conversations you're looking to mask. What we see here is what we refer to as our radius of distraction. This is really important because this concept really kind of helps drive home a point of what masking does in a very simple and visual graph. So if that's you right there, and you are being distracted by everyone you have there in that red circle, then what sound masking actually does is it shrinks that. We raise the noise floor and we bring it up to a point to where you're now only hearing the people basically in these two, maybe three cubicles next to you. And this is vital because if I take a real world example, in our office space, we've got nearly 100 feet in one way. Imagine a big rectangle, 100 feet going one way and say maybe 40 feet across. I could hear someone's conversation being at one far end of that rectangle, essentially the top left-hand corner, and on the opposite end of that 100-foot office, I could literally hear someone's phone call with our masking system turned off. I could understand a lot of what was being said, and that's way across the office. Now, as soon as the masking is turned on, I am now only hearing people that are directly next to me. And when I say hearing, I mean understanding them. Yes, I can still hear people further away, but I'm not going to be understanding their conversations. And that's absolutely vital to an effective sound masking system. And once you understand that, then you've really come quite far with sound masking. So what is sound masking? What does it actually sound like? So sound masking is the process of adding a low background sound. It's an engineered spectrum of sound to basically bring up the noise floor. A lot of people would like to hide it as something really quite magical, scientific, and it is scientific, certainly, but all we're doing is we're making the space louder with a very, very specific spectrum of sound that perfectly covers up human speech. What else would be speaking, I guess, unless you have a parrot or something like that. But bottom line is that it makes your space far more private. Ideally, what you're going to have with a sound masking system is it's not going to be overly loud. Now, there's a few different ways to look at overly loud. Usually, it's fairly clear, though. So we don't want a private office usually being any louder, and maybe 38 to 42 at the very tops. And for an open office area, about 45 to 48. Now, what's interesting is if you're not in the US, that changes as well. So the perception of buildings and the building noise changes internationally as well. So if you're, say, in Germany or Sweden, usually their tolerance for sound masking is a good deal lower than what we have here stateside. So they'll usually have a sound masking system set a bit lower. And yes, it is a little bit less effective, but it's still effective because they are, in general, a quieter bunch. So anyways, the sound masking has to be set to where it's not too loud, right? So within that 38 to 42 for a private office, 45, 48 for an open office stateside. But you don't want it to be too loud either, because then the sound masking can become annoying in itself, right? You don't want it to be so loud that now the sound masking is also causing a problem, but you want it to be loud enough to the point where it's effective. And usually with a sound masking system, what you get is you don't even realize that it's there. And we'll go over some of the principles and how we can actually achieve that. Usually, a good sound masking system, you will not even know you have it unless that system is, for one reason or another, turned off or rendered ineffective for one way or another. You don't know it's there until it stops working. So it's actually believed that one of the earliest examples of sound masking was the Romans using fountains to mask the sound of chariots on cobblestone. I believe that's a quote on Wikipedia put up there by Jack Hine, our founder, and he would certainly know. And you can certainly try to refute that, but good luck. So an interesting fact that I touched on briefly at the start of the presentation, but sound masking has actually been around since the 1950s and 1960s, depending on how you want to look at it. And an acoustical consulting firm in Boston, Bolt, Beranek, and Newman, BBN, were actually the ones that pioneered that first sound masking system based on Beranek's experience in a library. They spun off, they formed Acoustics, who's a world-class acoustical consulting firm. So if you're building a studio or something like that, you often reach out to someone like a Acoustics. Well, they spun off and then also formed Cambridge Sound. So hence a little bit of the lineage that we have. So some key elements to an effective sound masking system. The sound spectrum is absolutely vital. And I'm going to go over these just real quick as we'll cover them in greater detail here in just a little bit. The sound level, how loud it's set, like I mentioned before. The proper zoning, and then you've got uniformity as well. So the key elements. So sound masking is not white noise, and I'm sure you've heard of it referred to as white noise, if not referred to it as white noise yourselves. Heck, I've referred to it as white noise myself. However, it's certainly not white noise. There's few things that manufacturers of competing products usually agree upon. However, the spectrum of a sound masking system is one that sound masking manufacturers actually do agree upon. What you see there, that light blue kind of shading, is an acceptable level. You can be within there and be perfectly effective for sound masking. You can just shape the way that it sounds a little bit. Certain sounds are a little more pleasant or less pleasant to different people, so we want to shape it to make sure that it is as comfortable and as effective as possible. So this is going to give you an idea, and a lot of people, and this is a fun fact, I don't know if people usually aren't listening to me or what it is, but when I go through this and I ask the question, so what do you think sound masking is? And I usually make a case of what the sound pressure levels are set to before. And usually people will get this question wrong. I'm very impressed when they get it right. So hopefully you guys were listening, but we'll find out here soon enough. So a quiet library, right, is at about 30 or so dBA. And that just means that it's an A-weighted scale. An A-weighted scale is one that we use often for a typical office environment because it gets rid of a lot of the spectrums that we don't care about when we take these measurements. So an office conversation. So you are chatting with your colleague, and that conversation will likely come in at about 60 dBA. I'm not talking about, Friday, 4:30, getting out of the office conversation. That'll probably be a good deal louder. Typical office conversation, though, is at about 60 dBA. A vacuum cleaner will get you right around 70 or so dBA. Passenger aircraft, I should know very well because I'm on one 4 out of 5 days a week usually, puts you at about 85 or so dBA, depending on how close you are to the turbines or the prop or and where you're sitting. A power drill is more of a hammer drill at this point at 98 dBA. That is loud. Now, I'd ask for your thoughts on where sound masking comes in. I'm not sure how long it would take to get that here in the chats. If anyone wants to take a stab at it, that would be great. However, sound masking in this case comes in at 48 dBA, or 47. 48 being kind of the high end, 47 being kind of a nicer medium, just a little bit quieter than we want it to top out at. So another element that's absolutely vital for an effective sound masking system is the zoning. So here you see three separate zones, and we have these zones because they are different types of environments with a very different function and very different perceptions of what that sound level should actually be at. So my zone 1, and I'll just jump back here actually. So my zone 1 is my open office areas. That's going to be the loudest kind of area that I'm going to have. It is acceptable for the sound masking system to be a good deal louder there than it would be in, say, a private office. So there I can have that 47 dBA. In my second zone, I have my private offices. You walk into a space, a private office, the perception changes completely, doesn't it? It's a much smaller space, more intimate. So what you want there is a quieter sound masking. Not only that, not only did the environment change, but so did the physical properties of that space, right? You've now got walls, you've got doors, things that you didn't have in that open office area. So now you're able to have your masking set to a lower level and still be effective. So my private offices sit at about 38 to maybe 42 dBA on the high side of things. That reception area, that's an interesting case because we've got a couple of different things happening here in on this floor plan. We're right next to a conference room. We're also right next to the open office. And depending on the kind of conversation that they could be having in that conference room, there's a pretty good chance that it's going to be fairly sensitive. And seeing as you're going to have just about anyone sitting in your reception area, you know, it could be a competitor. So you'd want to have almost a very similar sound level in here as you would in zone 1, because you want it to be fairly loud so that those conversations from the conference room are not bleeding through. Or maybe even someone in the open office area could be having a conversation that you wouldn't want someone in the reception area to overhear. So another element is going to be uniformity. Uniformity is vital. Uniformity means that you walk into the space and, hey, this is my space. You don't hear the sound masking until it goes down for one reason or another. I'm not implying that it does go out. I'm referring to if you have a power outage, if it gets unplugged, something silly like that. You shouldn't be able to tell you have a sound masking system. If you can tell that you have one, then there's probably an issue. It probably hasn't been tuned right or installed with uniformity in mind. What happens is if you have speakers installed in certain areas, then you'll see a deviation as you walk from the side that has the speaker closer to it. You walk away from it, it'll obviously get a little bit quieter and then start to pick up again as you get closer to that second speaker. That's why when we design a system, one of the most important aspects is to have a grid pattern that's going to function to provide the best uniformity possible. That uniformity that we aim for is about a 3 decibel delta. So we look at maybe minus 1.5 to plus 1.5 decibels. And with a QT solution, which is a direct radiating solution, really we strive for a deviation of a single decibel. That's absolutely not noticeable. You can absolutely run around this space and you won't hear any difference whatsoever. That's, so here's a graph that kind of shows what that looks like. You know, if you have some difficulty imagining it, well, here you go. Here's the graphic to kind of explain what that actually would look like. Again, with that grid, we get perfect uniformity. So we have the most, as I mentioned at the beginning of this presentation, we have the largest selection of systems available through Cambridge Sound. We have direct field, which has empirically been kind of our bread and butter. And as of the summer last year, we acquired the absolute leading in plenum system manufacturer, Dynasound, who've given us the best in plenum solution. And we'll go over why that is. So basically, what you had is back in the 50s and 60s, essentially, when they first started making these sound masking systems, what you had were large speakers generating a lot of sound energy, and those were released up in the ceiling. and you'd have to have a ceiling plenum for this sound wave to kind of bounce around in. And then through the theory of basically diffusion, you would get these different speakers and their spectrums to kind of mix in that plenum space, and then it would radiate back down to ear level. So you'd have to generate a lot of energy, and it would have to penetrate whatever ceiling you have, and then it would come back down to earth or ear level. So the bleeding edge, as it were, back in '99 was with the QT technology, when Jack figured, hey, doesn't it make more sense to send the spectrum of sound directly to someone's ear, right? So very much like you have your stereo set up at home, you've got your surround system and everything else right there in front of you. You wouldn't put it up in your attic to watch TV in your living room downstairs. It just wouldn't really happen. So what Jack did was he devised these very small emitters, and they mount directly into the ceiling tile or onto the ceiling. There's a host of different mounts available for your particular situation. And then they simply send that spectrum of sound down into every given and very specific space. So we're able to tune exactly where we want and which sound. Also, we are indeed LEED certified, and we do provide LEED points. The requirements now that have been taken into account with LEED are very much what we spoke about before, the different elements that are vital to a sound masking system. So the speed spectrum has to be effective, right? And that's that blue shading that I showed you before. The design levels cannot exceed 48 dBA. If you didn't want to hear the person sitting right next to you, then you could go above 48 dBA. It would just be obnoxiously loud. And then a coverage uniformity of plus and minus 2 dBA. Bear in mind that that's a 4 dBA total swing. So some design issues that we encounter quite a lot. What can be done to increase acoustic privacy in your space? What are the best practices that we use? So with a goal of being from 80 to 95, some of the key metrics, sound masking can help a lot, but it makes our job even easier if some of these parameters are followed. So what we have is obviously distance, and that's more or less a losing battle because it's going to be tough to increase your distance. You usually already have your space unless you're out looking for a new one, and even then, because of acoustic privacy, it's going to be fairly rare that you can give an employee 200 square feet. It just doesn't happen. Brilliant thing is, with masking, we're essentially able to triple one's space. So if you have 80 square feet of space, you've really now got 240 as it relates to acoustic privacy. I can get into that in further detail later if you'd like. Head orientation is obviously going to be very important. Say you've got a call center, just any typical open office area. How you have your architect design the space so that it more or less influences someone to look a certain way when they speak on the phone, that'll also go a long way in making it seem like you have a larger space in regards to acoustic privacy. The absorption of your ceiling tiles, I've got a slide here coming up that does a great job of going over that. That's very important. That's one thing, in addition to masking, that you can do relatively inexpensively that has a huge result on the overall privacy index of your space. Of course, the effectiveness of your barriers. You may want to go with the glass because of aesthetic appeal, but certainly don't throw out considering, that grayish acoustical panel that's going to do a much better job of absorbing that sound and also quieting down the space. And then the background sound level. That's also very important. One interesting thing is I've seen a lot of new spaces get built out with extremely high quality ceiling tile, good carpeting, and an ultra-modern HVAC system so that they quiet down the workspace. Well, guess what happens? They succeed in bringing down all of that mechanical and building noise so much that that conversation that before in that same space wouldn't have been an issue because of the noise floor being loud enough to cover up the conversation. You've now made the space so quiet, in fact, that you need to go back and add masking to bring back that privacy that was missing without the masking. It's something pretty interesting, but I've been seeing quite a lot of as well. So this is, I really like this graph right here. This really drives home the point. So if we take your typical office space, all right, this is your office as you have it today, no changes. You don't have any sound masking. You have partition heights at about 48 inches or so. You've got a fairly standard ceiling tile rating of 0.5. Your average privacy index is going to sit at about 59%. We take that same space. You've now gone up to a really high quality ceiling tile with a rating of 0.95. All things remaining equal. You brought up that privacy index drastically. You've done that for a fairly minimal, $2 sign, whatever that correlates to, but it is relatively inexpensive. You've brought it up to 74% now. Now we're going to increase our blocking. This is one of my favorite methods because it turns it into like a fun maze kind of office may have had previously. So now we look at increased coverage, right? That's just masking. We add sound masking, everything remains the same. That privacy index jumps up all the way to 87%, and we've done so for a cost lower than just adding a better acoustical ceiling tile. So one thing that I'd like to have you consider that a lot of people don't is that just looking at masking, it may be able to get you to where you need to be. Not in every single case, but usually it's enough. So if you consider masking first, a lot of times when you're having these issues, it's something that you've already got. You've inherited the space as it is, and now it's up to you to make it better. Well, masking is one of those things that can really help out people in increasing their privacy, their productivity, and what have you. So other applications, this graph is kind of a gimme almost, because I'd be hard pressed to find a situation where someone doesn't have a case where they can overhear the person within the same space, they're being distracted, or where there's any kind of privacy concern, wherever those conversations shouldn't be overheard. Financial institutions, legal, healthcare, of course. You can really make a case for just about anywhere. So we've seen a lot and done a lot with healthcare type environments. We actually have a system dedicated purely to healthcare waiting rooms. We've got a lot of military and government projects. The space I was in yesterday that I can't really talk about is all pretty much secure. And with the Dynasound line, we are able to do the highest security type of environments now because they give us that capability. So if you're out there listening and you have a government facility or a military facility, we can absolutely help out with that as well. Legal, we've done a lot of law offices, local, domestically, and internationally. Certainly there's a lot to do in education. There's a lot of new collaborative type spaces where you've got, I was out at a college recently, and they used it in their technical space, which essentially is a library, or they had to put the word library in there, but really what it is an absolutely technical space. They had recordings, they had 3D printing running, and just different groups collaborating, and they had our sound masking installed on 3 floors, because otherwise it would have been really difficult to collaborate. There's a lot of cases in retail and public spaces, venues and events, sure, houses of worship, hospitality. We have a few hospitalities and spa chains that work with us, and then, of course, finance. So some quick myths about sound masking. HVAC is actually not a substitute for sound masking. Although a lot of times, and I've been in environments where the sound masking was basically functioning as a sound masking system, It's not. So if you are able to hit a spectrum of sound that fits within that blue shaded ideal spectrum, okay. But then you're also going to have your diffuser spaced so that you've also got that uniformity. So it's not noticeable. You'd also have to have it be a constant pressure system that's just always on and not turning on or turning off. However, because none of those criteria are met with an HVAC system, HVAC is not a substitute for a sound masking system. Sound masking does not reduce noises that are already too loud. I've had inquiries from dog kennels, shooting clubs, race tracks, bars, a lot of bars that are just too loud, and they want to be able to enjoy that show on Friday, Saturday, whenever. But at the same time, they want some of the participants to also be able to carry on a conversation. Well, we can't do that. We can't actually quiet a space. We're only adding additional background sound. So we don't actually quiet the space per se. We don't cancel sound. We're not noise canceling headsets. We don't actively listen to a spectrum of sound, send out the opposite of that to try and cancel it. And there's fundamentally a lot of reasons why that can't be done accurately. We just cover it up. It doesn't absorb other sounds. Again, we're just covering it. It doesn't block sound, unfortunately. For all of the times that I've seen designers try to implement our system in a kind of a curtain fashion, is not a magical spectrum of sound that's just going to block any conversation from one side to make its way over to the other. Unfortunately, it doesn't do that. It doesn't prevent face-to-face communication. You're still going to be able to talk to people that are located within 1 or 2 cubes away from you if that's what you like to do. You can still have your meetings. You can still have it in conference rooms. It's really when you fall out of a 12-foot or so radius that it really begins to kick in, and you begin to get a lot of muffled conversations that make their way over to you. Sound masking doesn't cause headaches. It's not detrimental to one's health. I tried actually telling that once to a holistic dental clinic in Detroit. It's a holistic dental clinic, yes. And all of their complaints went away, thankfully, when the doctor provided them with a magnetic bracelet to block EMI. So it's hocus pocus, really. All we're doing, if you recorded 100,000 people talking simultaneously and lowered that down to 48 decibels, you'd get this kind of a sound. You'd get so much. That's really what we're trying to emulate. So if someone gets sick from hearing people talk, then they might get sick from sound masking. But then there's a bigger issue at hand. It is not detrimental to health, again. So sound masking doesn't interfere with hearing aids or cochlear implants. And again, that's all due to that spectrum of sound is really just us replicating speech. So it doesn't interfere with that. So the benefits of sound masking. Thanks for adding this slide, John. I do like it, and it's something that was very missed before. So we increase productivity by at least 2 to 4%. I have to say that it's at least 2 to 4%. We're protecting speech privacy and confidential company information, and just the conversation that you may be having with your spouse. Improve acoustical comfort for office workers. Basically what we're doing is we're taking your cubicle space almost, if you're in a cubicle, and we make it so that it feels like it's 3 times larger acoustically speaking. And some of the benefits of working with us are we've got the richest heritage. Our Dynasound partners have been around since the 70s. Cambridge Sound has been around since 99. We have a full staff of engineers, acoustical consultants, acousticians, I should say, field salespeople. So we are just absolutely there to help you from the inception of your project all the way to the very end, and to handoff and everything else. So we're constantly coming out with new pieces of equipment to do sound masking and to do it better. There's different ways of doing it. All the manufacturers are doing sound masking in some way, shape, or form, but there's different ways to do it. And we are always trying to be on that to have the best method for the given situation. We are certainly able to do paging. One of the things that's come up in the past, especially very recently, I should say, not so much in the past, paging used to be, okay, there's an all call for everyone that used to have beepers. Now we're not sure where, person X is, so let's page them on this floor. Not so much anymore. Everyone has cell phones, right? So the real issue is doing it for some sort of a broadcast. It could be an emergency broadcast, it could not be. But we can certainly be used as a paging system for that. We can also do background music with the same system, and with the inherent advantage of that uniformity that we want to have with the sound masking system, we can now also use the benefits of that uniformity to do a page, to do music, without purchasing another system, all within the built-in functions of that sound masking system. All of our systems are networkable, which allows for easy control, customization, and basically integrating that system into your space. Now, they are really set it and forget it systems. Once it's installed, up and running, you usually just let it do its thing and collect dust. And no one notices again until there's a power outage or someone accidentally unplugs it, and all of a sudden everyone's overhearing everyone's conversations. It's kind of like whack-a-mole. All of a sudden you see people pop up from their desks and everyone's just like, hey, what happened? A lot of times you may not even know what happened. You just notice that something has changed. Again, we are the world's largest provider of sound masking systems, and we have all of the solutions to fit your particular need. We're trusted by over 40% of the Fortune 100 companies at this point. So what you should have learned is A, B, and C equals speech privacy. And that's going to be it. So any questions, feel free and ask away. We finished, I believe, just a little bit earlier, right on time. So if you have any questions, certainly let us know. If you'd like a copy of this webinar, we're certainly happy to help and send that over to you.
Thank you, Balazs. This is Ann back on the air. Thank you very much for that presentation, and thank you to all our attendees for listening in and for sending some of your questions in. We do have time for a few questions, so I will pose those to you. The first is about Cambridge Sound Management's offerings, and specifically, does your product or do your products work with open ceiling spaces?
Absolutely, and open ceiling kind of spaces are now becoming so much more popular, especially in city areas and kind of older mill buildings that have just become refurbed into these really cool new dynamic workspaces. They tend to be a bit of a nightmare acoustically, and all of our products allow for mounting to the deck, to the structural deck, to wood beams or steel beams, even to walls in certain cases, and that's vital. That really allows us to make it as easy as possible for an installer to get in and to install our products in open ceiling type environments, because there's certainly a need for it, more so oftentimes than ones with just an acoustical tile ceiling. So we have plenty of options to mount into open ceiling. Yes, that's a great question.
Thank you. So another question. Why not use soundproof walls, or I guess where might soundproof walls fit into the ABCs that you had been talking about? Where does that fit in, and why not? Why wouldn't that be the solution? I guess is the question. Can you comment on that?
Yeah, that's another really good question, and there's a few reasons for it. If you've got the money for it, by all means, go for it. They are brutally expensive, and they provide a given rating which is attained in a laboratory environment. So if you've got this really highly rated door, if it's not installed in that ideal, nearly laboratory type condition, then you're going to get a lot of seepage through that wall, a lot. So in just about every case, and even going back to where I was yesterday, which is essentially in a top secret type of an environment, and we're considering using doors that cost an upwards of $5,000–6,000 a piece. Depending on how it's installed, it may not come even close to that given rating that it should be able to attain if it was installed ideally. And then, of course, there's the issue of cost. For the cost of one of these doors, we can usually implement masking into possibly as much as 1,000 square feet of space. So it'll be more effective to go in with a sound masking system for a larger degree of space than that door would actually cover. So really it's just a case by case, but it's pretty tough to make a solid case for that door unless you are looking at a top secret type of a space or an environment. Yeah.
Thank you. So it looks like we have time for about one more question. So I just, let's see, we'll ask this. It has to do with the energy consumption of sound masking and your systems in particular. How much energy, or how is that quantified? How much energy does sound masking use? I know you mentioned, it's set it and forget it. So in terms of energy use or consumption, what does that look like?
Very minimal, and it purely depends on the type of system that's being used. Again, we do have multiple types of systems. The QT lineup is absolutely minimal. So previously, the example I would have used is we're able to cover 180,000 square feet with about 27 watts of power. So right around as much as you have an exit sign, an LED exit sign utilizing, we can power 180,000 square feet with something that you'd use to power that exit sign. We do, of course, have 70 volt as well. So depending on the application and a budget, we have networked 70 volt. We have the QT emitters, which are direct radiating. We have that QT active system, which gives us a greatly enhanced paging and music capability. So when we get into those higher rated or more for paging and music kind of speakers, those ratings or the energy consumption does go up. But they are all LEED certified, and we can literally go from a few milliwatts a speaker with QT to as much as a couple of watts of power consumption with the bigger ones. So it just depends on which system we go with. But in the long run, when you look at the cost savings of running a sound masking system versus not, that energy consumption aspect of it becomes absolutely negligible. So, yeah.
Thank you. Thank you very much. So it looks like we're out of time. I want to thank you, Balazs, again for your presentation, and to Cambridge Sound Management for sponsoring the webinar. And of course, thank you to our audience for attending and sending in your questions and comments. Also, I'd like to let you all know a recording of this webinar will be available online at facilityexecutive.com, as well as at the Cambridge website, and that's cambridgesound.com. So thank you very much, and have a great afternoon.